Consider y equals negative 2x plus 6. It's got a slope of negative 2, as we know, since this is slope-intercept form. Coefficient of x is the slope. Okay, well, the slope then is negative 2, and the y-intercept is 6. So we know this about the function. Now, what we want to explore is what would the slope be for a function that was for a function whose graph is perpendicular to this. Now, let's go back a second. If the graph is parallel, then it's going to have the same slope, because parallel lines have the same slope. If they're perpendicular, how do the slopes relate? Well, here's one example illustrated with this figure here. Here is a run of 1 with a rise of 2. Of course, this would then constitute a slope of 2. If we reverse the rise and the run and make one of them negative, well, let's make the rise into the run, but change its sign to negative 2. And then the run here will become the rise here. So we've switched the rise and the run and made one of them negative. So that means we go negative 2 units in this direction and 1 unit in this direction. It's not difficult to show that these two lines have to be perpendicular. And it's also very obvious that this slope would become 1 over negative 2, which is negative 1/2. And we notice that this is the negative reciprocal of this slope. If we have a slope of negative 2, which is what we have in this case, it means we go over 1 down 2. A run of 1, a rise of negative 2, giving us a slope of negative 2. Now, if we reverse the rise and the run and make one of them negative, well, this time I'm going to let the slope stay, take the rise, which is negative 2, and make that into the run. And then I'm going to take the 1 and make it into the rise, but I'm going to change its sign. Remember, I have to change the sign of one of these. So rise becomes run becomes rise, and one of them changes sign. If I do that, I get this picture, and again, it's at least plausible that this is a right angle. And it can easily be proven that it is. Well, the slope here is negative 2 over 1, which is negative 2. The slope here is negative 1 over negative 2, which is the same as 1 over 2, which is 1/2. Again, negative reciprocal. So we can make this into a rule. I don't expect you to be able to solve or to prove this, although if you want to really learn this stuff extremely well, I recommend that you use a little bit of geometry and prove that whenever you do this, the hypotenuse of this triangle will be perpendicular to the hypotenuse of this triangle. Okay. But anyhow, the rule is that lines are perpendicular if, and only if, to be complete, their slopes are, and I never finished my sentence, did I? If their slopes are negative reciprocals. Okay, so we're going to test a few lines to see if the slopes are negative reciprocals. And in some cases, we're going to have to do just a little bit of work to find the slopes. Okay, so we have the line y equals negative 3x minus 9 and 3x plus y equals 2. Now, how are we going to compare the slopes? We're going to put each line into slope-intercept form, meaning we're going to solve each equation for y, and then be sure that we have the solution expressed as some multiple of x plus some other number. So we'll have the slope in the intercept. Okay? We don't need the intercept to prove that lines are parallel or perpendicular, although the intercept tells us a whole lot that we would want to know. Okay, well, okay, this is already in slope-intercept form. We see the slope is negative 3. This isn't, but if we subtract 3x from both sides, it now is. So y equals negative 3x plus 3. We can see that this slope, being the coefficient of x, is also negative 3, so that if we were to graph these two lines, and I recommend that you actually graph some lines, that we see that the two lines are very plausibly parallel. And again, from what we do here, we know that the slopes Well, the slopes are the same, so the two lines have to be parallel. We don't have to use those. Okay, now, another example. 2x minus 5y equals 4. Y equals 5 half x minus 1. Well, we immediately read the slope here. It's 5 halves. Over here, how do we get the slope? Well, I kind of bunched stuff up down here, but the resolution of the camera should accommodate this easily. Okay, so we solve this for y. First, we subtract 2x from both sides, giving us negative 5y equals 4 minus 2x. And then we divide by negative 5. Okay? Dividing both sides by negative 5, we get y equals our 4 minus 2x divided by negative 5. Now, when I said solve the equation for y, a lot of people solved the equation and stopped here. And there's no reason they shouldn't have, because I didn't specify that you want to solve the equation for y and then express it in the slope-intercept form. And this isn't quite in slope-intercept form. Now, it will become slope-intercept form if we use the distributive law and get 4 over negative 5 and then minus 2x over negative 5. And then minus 2x over negative 5 is just 2x over 5. That'll be added to 4 over negative 5, which is negative 4/5. And we get the slope-intercept form. 2x over 5 equals negative 4/5, and we can see that the slope is 2/5. So the slope is 5 halves here, it's 2/5 here. Does that make the lines parallel? Well, obviously not, because the slopes are different. Does it make them perpendicular? We've got that reciprocal thing. Well, we do. The reciprocal of this is this, and vice versa. But this isn't the negative reciprocal. So it's the reciprocal, but not the negative reciprocal. And remember, when we do this, we will get a slope of opposite sign when we get the slope of the perpendicular. So, almost but not quite. But this illustrates solution of an equation of this form to see what the slope is. Okay, up here, well, again, these are two equations where you can easily read off the slopes. 2/3 and negative 3/2. Well, okay, so the slopes are 2/3 and negative 3/2. These are negative reciprocals. The reciprocal of 2/3 is 3/2. Then you make it negative, you get this. And vice versa. If you take the reciprocal of this, you get negative 2/3. Make that, take the negative of that, you get 2/3. These are negative reciprocals of one another. Now there's another example where you were given two sets of points. Okay, you were given the points 3, 7 and 9, 3. Okay, and also the points, I have to read it here, negative 4, 5 and 0, 11. Okay, so we have the line between those first 2 points, and we have the line between the second 2 points. And actually the first 2 goes down, second 2 goes up, but that's okay. So we have the lines defined by those 2 points. Now we could, if we wanted, because we have learned how to do this, we could actually, if we wished, get the equations of those 2 lines and look at the slopes. However, if you're given 2 points, you can find the slope and you don't have to find the rest of the equation of the line unless there's something you need the rest of the equation for. So we take our first 2 points, 3, 7 and 9, 3. We do a fundamental triangle, run of 6, rise of negative 4. So the slope is negative 4 over 6. And of course we reduce this to lowest terms to get negative 2/3. Because we're going to want to compare it with the slope here, we want it to be reduced to lowest terms in both cases. Otherwise, it might not look like you have what you do have. Okay? Then here, we have negative 4, 5, and 0, 11 as our 2 points. Well, we do a fundamental triangle. We easily find the slope. It's going to be 4 over 6, which is 2/3. Okay? Now, are these slopes the same? Well, no, because this one's negative and this one's positive. Okay, are they negative reciprocals? They're negative. Well, they're not reciprocals. You got a negative 2/3 and a positive 2/3. The negative reciprocal of 2/3 would be negative 3/2, not negative 2/3. So, these lines would be neither parallel nor perpendicular. So these are various ways in which you can get the slope of a specified straight line. Dan? You see how they're compared in order to determine if the lines are parallel or perpendicular.